So I think we'll go ahead and get started. My name is Bill Shin. I'm a Principal Security Solution Architect for Amazon Web Services. And for the last almost 2 years now, I've had the pleasure of working in our healthcare vertical. I am amazingly humbled by the fact that over 620 people registered for this session. This is the first year that we've had our healthcare track, and I absolutely never would have dreamed that this many people were going to be doing healthcare in the cloud 2 years ago. It is shocking the amount of adoption, the number of customers we talk to, and the workloads that are moving into the cloud. You saw Siemens in New York in the summer. You saw Philips today, J&J, big names. And we have some great customers to come on stage with me today from MDON, a partner from LogicWorks, and a startup, a very exciting startup called Aplible that will be talking about healthcare and architecting for HIPAA compliance on AWS today. So why is this a 400-level track? In the track description, we talked about how bringing engineering and compliance together in the healthcare space is a really interesting problem. So hopefully, for the engineers in the room, the developers, the sysadmins, you'll get a sense of what it takes to align your workload on Amazon Web Services to HIPAA from a compliance perspective, and what your compliance people and what your regulators and auditors would be looking for. And also for the compliance folks in the room, show you a little bit of the art of what's possible. Using cloud technologies and AWS services, it's possible to make compliance a heck of a lot easier. And hopefully for everyone, have a big hug at the end, compliance people and engineers together. So we'll start a little bit for the first 10 minutes or so about Amazon's HIPAA compliance program and what we put together over the last few years. This is really the first time we've talked publicly about some of the services and some of the way we work with healthcare customers to help them align and architect for HIPAA compliance. We've had a very strong presence in the healthcare space and life sciences space since our beginnings. Most of the genomic workloads you see on clouds are on Amazon Web Services. We have folks like DNA Nexus, Illumina, Seven Bridges, SciApps, all doing amazing work in the genomics and life sciences space. We've had healthcare companies, providers, payers, clinicians, bioinformaticians storing information on Amazon Web Services for years. In January 2013, as everyone is keenly aware in the healthcare community, the Omnibus Final Rule changed, and it changed the definition of what is a business associate. So we've been asked for a while before that to sign business associate addendums under HIPAA. It's a contract, sets the terms and obligations of parties in a relationship under HIPAA. So when the law changed, we took a poll of customers. We built a strong pool of providers, university hospitals, startups, payers, insurers, and we got together with those customers and our lawyers, of course, and worked out what it would mean to have a business associate program. Our compliance team and our internal security teams came to the table, and solution architecture, field sales, we all got together and decided what it would take to run a program to support HIPAA compliance and to be a business associate. It's a little bit different as a cloud provider in the sense of a traditional business associate. We don't have access to know what the data is, it's just bits. So it's not feasible for us to, say, notify a specific patient of where their record is necessarily. You, as the customer, control those bits on top of Amazon Web Services. It's also, the nature of a cloud provider is we're not a billing provider, we're not a clinic, we're not a laboratory per se. So we don't need access to the patient data to deliver a service to you. So that model for a business associate is a little bit different. We started signing business associates addendums and agreements in 2013, about Q2. I signed hundreds and hundreds and hundreds of them since then. And it's really based on the notion of a shared responsibility model. So what I'll go into next is kind of how we talk about aligning your workload on top of Amazon with regard to the shared responsibility model and with regard to what it means for HIPAA compliance. So in the commercial space, maybe not as many people are aware of our FedRAMP authorization. FedRAMP is a program for the government to procure cloud services. It's just an authorization. So we have agency-level authorizations to operate from Health and Human Services, large customer, Department of Defense, also a large customer. To get those kind of accreditations and then authorization to operate, you have to go through a very, very exhaustive audit against the NIST 800-53 control framework, or control catalog. So Appendix F of that catalog, if you printed it out, is probably about this, like, yay tall, the water bottle. And it lists hundreds and hundreds and hundreds of controls that you have to meet as a provider with regard to security and business continuity and all the things that go into getting that authorization. NIST also publishes a document called NIST 800-66, which conveniently for everyone in the healthcare space maps up the individual implementation specifications of the security rule in HIPAA to NIST 853 controls. So when you look to architect on top of Amazon Web Services, for the things that are in the portion of our portion of the shared responsibility model, physical infrastructure, the underlying substrate of the network, the hypervisor, the way we operate as an organization, the way we build our program, the way we manage access control and audit internally, all those things have been authorized to operate and accredited against the NIST 853 framework, to which, through 866, is mapped to the HIPAA Security Rule. So if you're preparing for an OCR audit, if you're preparing, Office of Civil Rights, if you're preparing for internal compliance efforts with your internal security and compliance teams, the things that fall into our shared responsibility model, you can use our FedRAMP authorization and the NIST 853 control catalog to demonstrate control effectiveness. For your portion of the shared responsibility model, things that fall up above in the guest operating system and above in the application stack, the way users access PHI through your systems, those are still the controls you need to own and manage. But we're removing the heavy lifting for many of the controls in the HIPAA Security Rule through our accreditation under the FedRAMP authorization. For that reason, we don't make all of the services in Amazon Web Services available for processing, storing, or transmitting electronic protected health information. You can use all of the services in a HIPAA account that's covered under a business associate agreement. I want to be very clear about that. You can use Route 53. You can use CloudWatch. You can use Identity and Access Management. You can even use RDS. You can even use DynamoDB. But it's very important that you put the PHI only in the eligible services listed here, because those are the ones that have gone through the FedRAMP authorization. All of our services have a very rigorous security engineering process. Some of them, like I already have email asking me if I can put protected health information into Aurora. It was about a 30-minute wait before it happened. So when we launched Workspaces last year, it was about a 10-minute, then the email started coming. Can I use Workspaces for protected health information? It hasn't gone through FedRAMP yet. This is a customer-obsessed thing that we do. We would not want to put you in a position to put protected health information into a service that we don't feel hits the highest of the high watermarks of our accreditation programs. All of these services have been through ISO 27001, PCI, our SOC 2, and the FedRAMP authorization. So we're very, very proud to offer them for processing PHI. But it's in your best interest to use the ones that are eligible. A couple of other configuration requirements. I have a lot of phone conversations with folks in solution architecture and engineering in the healthcare space. And the first one there, we want to raise the bar. The questions are always, why do you require us to encrypt data at rest and in transit, even throughout the entire VPC? And that's kind of hard, maybe people say. I say, what are you doing today on-prem? And oftentimes they're not even encrypting at all. And we want to be held to a higher standard, right? We want to raise the bar on security. People are moving to Amazon Web Services because they think they can do that. In particular with PHI. You don't want it on a desktop. You don't want it on a laptop. You don't want it on a removable device. People are moving it to the cloud. But we do require that it be encrypted in transit and at rest everywhere. Dedicated instances and recording and retaining activity with regard to the use and access to PHI. Again, we don't need access to the PHI to deliver a service to you. It's just bits and packets, and we don't know if someone's accessing one of your patient records. So as required by law, and just good practice, you need to audit that in your application. The dedicated tenancy, I get asked about this a lot. We want to simplify the process. We have one operating model. And as we moved into this space, we don't ever want to have questions about hypervisor security. We feel very, very confident in our hypervisor security model, but this is early days in healthcare on the cloud. This is the first time we've had a healthcare track, and it simplifies the conversation as we talk to providers and payers, and as you as SaaS providers or solution integrators or startups have those conversations, it simplifies the conversation. This is just an example, but this is one way in which, as we talk to customers, they've mapped their controls to the HIPAA Security Rule. The Office of Civil Rights publishes the entire Business Associate Addendum audit protocol. So it's available on the HHS website. I've just taken one simple control. So for example, the idea of auditing controls, or auditing the implementation specification for auditing access to PHI. So in this example, I've added a customer responsibility and an AWS responsibility. We both have a responsibility. So we have a responsibility under the hood to audit the API activities and audit changes to our infrastructure that could affect, have impact on customer content potentially, or systems containing customer content. You have a responsibility in your application to log access to that PHI. So it's a shared responsibility. But this protocol is published, and it's line by line, everything you would expect to see in an OCR audit. And we highly encourage customers to take a look at it and prepare your interpretation of that audit protocol. This is a simple reference architecture that we provided to customers when we're working with them on how they can architect a typical web tier. This doesn't include an application or data tier. Within the obligations under the business associated addendum and using the eligible services. So in this case, traffic is encrypted in transit through the ELB running in TCP mode. It terminates on HA proxy where you control the keys for SSL termination on dedicated tenancy. And it performs, if you need session state, you don't have to use HA proxy. And then it performs re-encryption of the session and sends that down to a web tier running something like Tomcat or Nginx or Apache. So as you can see, we've aligned our program to 853. We talk about the eligible services in our business associate agreement and talked a little bit about how you can map that responsibility to the OCR audit protocol, and finally a little bit of a reference architecture. So I'm going to turn it over to Dan Stover. Very happy to be working with Dan. He's from MDON, and he'll tell you about how they're architecting on top of Amazon too. Thanks.
Hi, everyone. So I'm Dan Stover, and today I'm going to talk about how automation and change management within our environment has really enabled us to naturally hit a lot of the HIPAA requirements from the perspective of a development team. So I work with MDON. MDON does a couple things. They do revenue and payment cycle management along with clinical information exchange solutions. So fundamentally, they sit in the center of payers, providers, and patients within the US healthcare system. The application I'm talking about today fits squarely within this context. To give some sense of the scope of the application, it involves tens of millions of these entities. So here's a timeline of what happened within our development group. So in March of this year, 4 of us showed up in an office in Seattle. And we didn't even have laptops at the time, and we had a handful of mandates, right? We had to build this application. We had to build out the engineering team to support building this application, and we had to do it in the cloud. Today, we have about 15 people on the team, 15 engineers working together, and we built out a relatively complex application. We have something like 45 EC2 instances today. ELBs, we have security groups, tons of different AWS resources which make up this application stack. And all of this is managed as code, right? We use CloudFormation templates to manage all of this. In terms of automation, over the 7 months, we've built over 1,200 AMIs in an automated way. We've brought our application stack up and down 500 times. And we've done over 3,000 zero downtime deployments of the custom application code into our application environment. So some general just comments about automation and change management, things that have driven the way that we work. I think the fundamental thing is that change is going to happen, and you need to deal with that in a very agile way, right? And this doesn't mean that you're going to be making changes in a reckless way, right? So using the appropriate tools and processes means that every single change you make is going to be completely transparent. You will know who made the change, why they made it, when they made it. And as you move into the cloud, the software architectures clearly become a bit more complex. There's a lot of infrastructure to manage, and you really need to be able to manage that well to enable your development teams to move quickly. And finally, by focusing on automation from the beginning, the end of this path is we're going to be deploying an application into a production environment. It means that you're going to have tools that are actually doing that for you. You're not going to have people logging into a production account to make these changes. So here's kind of a high-level overview of the architecture that we use. It's a pure VPC configuration. Our pre-production VPCs, they live in one AWS account. That's where the developers live and work. And then we have a management VPC, which has various tools that we use along with the production VPC in a wholly separate account. And there's a handful of tools that really enabled us to move forward quickly. So first we have Jenkins, which is our continuous integration server. This is kind of the heart of the development team. There's a bunch of automated jobs that run in there. We use GitLab for version control. So this is, standard kind of source control. But a developer is working on either infrastructure code or custom application code. They check something into GitLab, it's going to send a notification off to Jenkins, which is going to run a job. The end result of all of the Jenkins jobs, right, is a set of build artifacts. And these can be things like CloudFormation templates, the scripts that we use to orchestrate how those CloudFormation templates are going to work in our environment. And more traditionally, you can have compiled code that is the output of what the development team is building. We also wrap test results. We push test results into our Nexus repository, API documentation. So once those artifacts are into Nexus, our production engineering team is using Rundeck. So again, this is kind of a workflow service, but Rundeck is notified. A developer says, hey, I have a set of artifacts that are ready to be pushed into the production environment. Rundeck will reach out into Nexus, pull those artifacts down, and apply them into production VPC. The next thing to notice here are the different types of stacks that we bring up. And I think this indicates that an organization, beyond just the development team, systems administrators, network engineers, there's lots of people who can use this. We have an IAM stack. So in our CloudFormation templates, we define the permissions of what our users can do in our environments. We have network stacks. So these will actually go off and create VPCs for us. These will go off and create subnets for us. We have things like transient AMI stacks. It's basically a factory that creates AMIs that are used in various application stacks or application servers or web servers. And then kind of at the heart of it, we have stacks that correspond to our actual custom applications. So now just kind of hopping into the actual HIPAA controls that automation has really helped us hit, again, in a natural way. But for access control, I think it's a really compelling story to say that it's not people who are logging into an account and making changes. To say that it's a tool that's driven by automation that is fully transparent, I think that's a really good story. And there's kind of two AWS resources and services that help us do this. First is CloudFormation, right? And this really is the basis of how our infrastructure is managed. And we work on these CloudFormation templates in the same way that we work on application code. In our IDEs, right, the infrastructure definition is right next to the custom application code, which means you're checking that stuff into your version control system. You're getting all the history, and you can see deltas, what exactly changed, when did it change. And then by using the tools to work on that code and the resulting artifacts, all those tools have great logging in them. So when someone actually took that and, say, spun up an application stack, or precisely, did they add an ELB, did they add an application server? There's a ton of transparency in that. The second service is IAM roles, right? So all of our application servers and web servers have roles applied to them. But more importantly, it's like our Jenkins and Rundeck servers that have roles applied to them, and there's a very explicit set of things that they're allowed to do. So again, people aren't going to log into the production account. It's our tools that are going to make those changes. So audit controls. I'm going to call it CloudTrail here. That doesn't really have anything to do with automation, but it's simple to turn on. It will log all of the AWS API calls that you make into an environment. But because all of our infrastructure is managed as code, and right? We have these tools that are actually orchestrating the way in which these are applied in our environment. We have full transparency into where everything came from. In terms of, say, OS patching, just a story of how this works for us. So our systems administrators and security team, they work together to create a base set of kind of hardened gold AMIs that the rest of the organization uses. So when it's time to apply an OS patch, it's probably 3 or 4 minutes of keyboard work for a development team to grab that new AMI and get it deployed into their environment. It's a really kind of seamless process for us. Okay, integrity controls, right? So the thing that automation really enables us to do here is, again, there's a very limited set of people who can have access to our production account, right? So we never use PHI in our pre-production accounts, and we build out the automation there, and I mean, that means that we, again, only have to have our production engineers ever interact with the production account in any way. I'll call it here that we, at an application level, we persist all transactions that come into our system and all the hops, you know, through the various services in our system. Those are all persisted to S3 in raw form. And finally, I'm just going to say, right, you're going to have a backup policy. You need to back up your data, and it has to happen in an automated way. And I'm going to close with transmission security, right? So AWS doesn't solve this for you. Automation doesn't solve it for you. But the way in which these things can enable you to solve these types of problems is really amazing. So 3 or 4 months into our project, we probably had 30 or 35 EC2 instances running. And we decided it was time to implement SSL across our stack. So it took me 2 days from start to finish. And during that time, I never once logged into an instance to make a change, right? You do all your work in your templates. It's all tracked in version control. It's tracked by your by whatever servers that are applying the changes. It was really dead simple to get point-to-point encryption in place. So I think that's it for me. Thanks everyone, and I'll be hanging around afterwards if you want to go into more detail on this. I'm going to hand it over to Jason from LogicWorks.
Thanks, Dan. Good morning. I'd like to first of all echo Bill's sentiment about being very impressed with the turnout here. I guess I never realized there were this many healthcare geeks, but there are. So I'm Jason McKay. I'm the VP of Engineering for LogicWorks. A little bit of background on us very quickly. We're a managed service provider that's been in business for about 20 years. We focus on keeping mission-critical, highly complex applications up and highly performant. So for the last few years, we've had a focus on healthcare and PCI and other compliant industries. In 2012, we became a partner of Amazon's, and we started managing workloads on Amazon's platform. The advantages that we saw there were manifold. So the ability to turn up complex applications very, very quickly, and to iterate over those designs and modify them as you saw room for improvement was a key focus for us. So a few years ago, we took on a new client, which was Orion Health. They're responsible for spinning up, I think at this point, over 25 states' health information exchanges. Very, very rapidly iterating, very rapidly growing company. So I think in the time that we hosted them in a private cloud scenario, they've grown about 1,800% in terms of VMs as they scale. So this is very, very rapid. So there came a time when they were ready to deploy a version of their application running on AWS to take advantage of that agility, that global reach, and some of the business drivers there. So we were able to work with them to take the application stack and reproduce it on Amazon and incorporate a lot of the features that you've heard about earlier today to facilitate the compliance aspect of that build. Now, just so you understand some of the background where they were coming from, this was a very kind of bog standard traditional legacy data center deployment on private clouds. So we've got, our big name vendors in storage and hypervisors and networking, et cetera. We were able to move very quickly just by, the nature of our business, but we were still always hampered by those common things like lead times on acquisition of equipment and such. So we were able to say goodbye to all of that and move incredibly quickly going forward. And am I going the right direction? Yes. Okay. So first of all, we didn't know the total number of subscribers here, so scalability was key. We had to be able to move this very quickly to accommodate the demand. The timelines were, to put it politely, aggressive. There was a lot to be done in a short period of time. I'm sure, based on the chuckles, that a lot of you have dealt with those kind of timelines before. We were able to iterate quickly through the original sort of dev test deployments. Can we stand up something and test it for meeting basic criteria? And then can we tear it down and can we redeploy it, making refinements based on what we learned? Right, so some of the Amazon tools there were key. Obviously, CloudFormation has been referenced already. That's something we use on a regular basis, so we can make slight modifications, tear down an environment, redeploy it, test it, see where it works, et cetera. So we do that multiple times during the course of this project. And this is still ongoing, just to be perfectly transparent. So we've had several iterations through some of these environment deployments, and there will be more before we're done. So some of the things that we took advantage of by moving into AWS were, some of the common advantages that you get immediately. We heard Andy Jassy talk about the availability zone aspect, the fact that these are multiple data centers in each region. The ability to provide that kind of redundancy and availability, which is a key aspect of EPHI, is made much simpler by the ability to architect across multiple availability zones and even multiple regions, right? Some of this just seems like common, highly available application stuff, but it has a particular relevance to healthcare applications. Some of the basic things that we were able to use that were just made available, some of them within the last year, that we've taken pretty heavy advantage of. Encrypted EBS, that for us was a huge one. So in prior environments, we've been using third-party encryption tools, which work, but now we're managing the keys for that. That's cumbersome. That's, I think, Bill referenced how difficult that could be a little bit earlier. So this abstracts that portion of it away. We could still, if we chose not to put our faith in the key management system, we could use a third-party encryption tool on top of this. But we found that this is incredibly enabling in terms of rapid deployment and in trust that what is getting written to disk is being written to, is being encrypted at rest. So that was a huge thing for us. Identity access management. I can't say enough about this service and what it is that we can do with it. So I'm sure everybody's aware of the basic best practices about controlling, what an EC2 instance can do in terms of making API calls, right? But there's a lot of other areas there as well. So we're using Amazon S3 as one of the methods of sort of transferring data across portions of this application. The ability to write bucket policies that can completely lock down who has access to do what kind of action from what IP address to enforce that any put into the bucket is done with server-side encryption enabled to ensure that nobody can even accidentally put something into this environment that doesn't meet some of those HIPAA controls is key. So identity access management is all throughout whatever it is that we deploy. There's a lot of performance architecture work that goes into this as well. We're still using some fairly legacy sort of commercial relational database products, right? So, and those are very I/O dependent. So, some of the capabilities of EC2 rather with EBS optimized instances, the ability to sort of multiplex multiple instances to get more throughput to storage, to take advantage of provisioned IOPS, and then now across the board to have default SSD-based EBS volumes everywhere has been a huge advantage to us. Auditability. So we actually partner with AlertLogic, who's been a great partner of ours, to provide two primary functions in all of our HIPAA environments, whether it's on private cloud or public. And that is Threat Manager, which is essentially an IDS. They've done a wonderful job with integrating with Amazon to make that very kind of AWS friendly. And that allows us to do intrusion detection across all of our EC2 deployments. And then we also have Log Manager, which is basically a syslog aggregator, which will allow us to set triggers for access to certain pieces of information. If we can get it from the application into the log stream, we can alert on it from the alert logic side, which is very handy. And we also can plug our CloudTrail into that. And CloudTrail has been something that we also make heavy use of. And as others up here will mention, that's absolutely essential to being able to alert on, let's say, API access or API access attempts from an IP address that is not whitelisted. We can say, okay, somebody's knocking at the door a little bit too hard here. We need somebody to take some action on that. So I'm just going to walk through now sort of high-level overview of the sort of network and VPC topology that we're using. So for this particular project, we have split out the kind of central management area from the client-specific area, and we've done that actually even at the account level. So we basically, as I mentioned before, make good use of the spread across multiple availability zones, multiple VPCs, lots of VPC peering in place here, extensive use of network ACLs and security groups to isolate access. So we're looking right now at these sort of customer specific, and then we've got a kind of management overview of this as well. So what we can do is we can actually lock down the access into the environments through bastion hosts that are only enabled from one environment into another, right? So we can put session recording software on that. We can get a real kind of tight security model around it. This allows us also to make sure that the sort of number of users that are available at the API level in the customer-specific environment can be quite low, right? If most of our management is done from this other environment, we have less moving parts in the area where the actual EPHI lives, and that's architecturally that's a sound thing for us. And we don't have to walk through all of these because there's quite a bit here in terms of how this actually applies to each one of these areas. But one of the things that we make a lot of use of is single sign-on. So the SAML Active Directory integration, so we can keep our user management in an area that everybody's familiar with, and we can do password complexity enforcement, we can do password rotation, we can do user lockout, we can do all that sort of thing in Active Directory, which we're all pretty familiar with at this point, and then simply have that now also apply to API and console access on Amazon itself. I think we talked a little bit about the encryption at rest, and I won't go into all of these, obviously. Audit controls with CloudTrail, that's absolutely key, and Log Manager for that. One of the other things that we're looking at that we do quite a bit is backups and availability or durability of the data is very key. So we're doing regular snapshots, obviously, at intervals that are predetermined based on the RPO and RTO of a particular data set. But we need to make sure that if those backups don't work, somebody knows about that and somebody takes action. So we're doing the typical quiescing of volumes and snapshotting and that sort of thing, but we also take all of that, automate it on a regular basis, and then we measure the output of that, and if there's a failure, we publish a CloudWatch alarm so this gets in front of our 24/7 knock, right? So now somebody can say, you know what, backups failed on such and such volume. I know we don't have a good backup for that night. And then they can go back and address that. So what does this allow us to do overall? We're able to take advantage of a lot of the tools to ease some of the compliance management around things. But really what this matters most to, and I think most people are familiar with this, is the business requirements here. We're able to move very, very quickly, able to iterate, improve, constantly improve the environment, and when required, the spin-up time to move this into a new region or to make a slight copy, a slight modification of this application stack becomes something very, very achievable. So with that, I will pass the baton to Frank from Aplible.
Thanks, Jason. I'm Frank, co-founder of Aplible, and we are a hosting platform that tries to abstract much of HIPAA for application developers. More broadly speaking, we're trying to make it easy for developers, dev teams, and innovators to work in healthcare. So when we talk about HIPAA, most people don't get excited right away. But at Aplible, we actually are excited about HIPAA because we feel that we're just entering an age where HIPAA compliance is becoming manageable, processes are becoming standardized for dealing with it, and we sense that there's going to be huge disruption in this space in the next several years. But in order to dive into HIPAA and to see why it's manageable, we have to understand why it's been problematic historically. So the two big challenges with HIPAA are that it's very complex and its requirements don't always map perfectly onto engineering protocols and best practices. So as a result, a lot of organizations deal with HIPAA and compliance in general as though it's a completely separate process from engineering. They'll build an app, deploy it, and then address compliance after the fact. But this creates a lot of repeated effort securing and making apps compliant that actually share a lot in common. So today I'm going to show how we can use different layers of responsibility to solve HIPAA problems generally across apps and minimize the amount of extra work required to make each new app compliant. So to start, let's define what we mean by layers of responsibility. So HIPAA has three types of safeguards. There's the physical safeguards, technical safeguards, and administrative safeguards. We're not going to talk about the administrative safeguards right now, so let's just focus on those first two. So physical safeguards are fairly straightforward. They address how the physical resources on which PHI are secured, maintained, how physical contingency plans are set up. That's generally the sort of stuff that you don't have to worry about if you're deployed on AWS. We like to split up the technical safeguards into two components. General safeguards, which apply to any application that you might deploy, and then application-specific safeguards. So general safeguards include things like encryption at rest of, say, EBS volumes, encryption in transit, backups, SSH access to the instances where applications are running. And then some of the specific technical safeguards include authentication, access controls, request logging, the sort of stuff that you might have to implement on a framework-by-framework or application-by-application basis. In terms of Aplible, these different layers also correspond to different tiers in the architecture. So at the base layer, we have AWS taking care of the physical safeguards and many of the general technical safeguards. Aplible handles the rest of the general technical safeguards, and then our customers are responsible for just the application-specific technical safeguards. So I'll show how our architecture is set up in order to try and motivate how we're able to isolate those application-specific safeguards. So on the left-hand side here, we start with CloudFormation templates that generate a unique VPC and an OpsWorks stack for each of our customers. That OpsWorks stack includes chef recipes that install Docker, set up basically all of the security systems on the machines, and install our custom proprietary pass tool that does all of the operations that you'd want from a pass. So managing deploys, configuration, setting up vhosts. And then on top of that, we run Docker containers, which are given to us by our customers. So they can specify this via an API. They can git push, like you would with, say, Heroku. And all of the application-specific safeguards are addressed within those Docker containers. And then finally, on the tail end, we're of course using CloudTrail to monitor all AWS API requests for future audits and reporting. So the general technical safeguards are all covered by the CloudFormation templates that we use and the chef recipes that we run. One of the great things about using Docker for our customers' applications is that it gives us a standard way in which all applications are deployed. So specifically, how the network interfaces are configured on these containers, how data volumes get mounted in. that's the same across all of our customers for every single Docker container. And so we can come up with general solutions for securing those. So the CloudFormation template sets up a secure network layout. The OpsWorks recipes and our custom tooling manage the general security functions and wrap those Docker containers in order to provide SSL termination, volume encryption, continuous backups, all other general safeguards. And then the applications run within these Docker containers and manage their own framework-specific security controls. So let's go into a couple examples of the general safeguards and how our system addresses that. So one general safeguard is unique SSH identities. This is a subset of the safeguards addressing unique user identity. By using OpsWorks and IAM, we're actually able to automatically have one user, one Unix user per human user, and one authorized key for machine or device that user is using. This is exactly what we want for having unique SSH identities across our instances. There's other potential solutions. You could have a set of custom chef recipes that pull from a data bag that maintains your dynamic set of authorized keys. But really, we found that IAM and OpsWorks is the easiest solution here. One other way that OpsWorks helps us enforce security at the general level is by enabling us to have a deny by default policy for SSH. So what I mean by that is that we only grant SSH access to an IAM user and only on a temporary basis. So every hour, we have a chef recipe that locks down the instances. It basically goes through all of the permissions on the stack and removes access to all users who currently have access. We have a simple command line tool. It's just a Ruby gem. You can gem install OpsWorks CLI that manages some of these functions. So you can, for example, allow a user on a particular stack or lock down that stack and deny access to all users. So with this denied by default policy, we're actually able to easily audit SSH access, because anytime a user logs into a machine, it's only because they were explicitly authorized by running this OpsWorks allow command. And because we're using CloudTrail on the tail end, that ends up in our CloudTrail logs. There's other ways that you can do this. You can use third-party solutions, but ultimately, they end up being a lot more complicated than just relying on CloudTrail, which is a great solution. So I'll just very briefly talk about how our customers address the application-specific safeguards and how we're able to simplify that process as well. So the problem here is that there's tons of frameworks, tons of libraries. Our customers are using Rails, Django, Flask, Node.js, Java-based apps. And each of these frameworks has its own specific implementation decisions. So we maintain a single compliance API that represents the important audit artifacts that need to be maintained and map them back to the regulatory requirements. So one example is that our compliance API client can register an authentication event, tying it to a specific timestamp, a unique user ID, and then an authentication method, along with other parameters. And then on our back end, this ends up mapping to several different HIPAA requirements. And we can keep track of that all. And so it's not necessary to have this explicit mapping from audit artifacts to regulatory requirements. But the big takeaway here is that it is possible to abstract these requirements in a way that makes sense for DevOps and to generally solve the problem across all of your apps instead of focusing on an app-by-app basis. So with that, I'll hand it back to Bill, and thanks very much for your time.